Alright, chapter 27, this is sub-chapter 2, tires. Tires are hollow, donut-shaped structures designed to provide traction to the wheel assembly and act as a cushion to absorb shock from the road surfaces. The air in the tire supports the vehicle's mass, and the tire tread provides frictional contact with the road surface so the vehicle can maneuver safely. The tire itself is generally composed of tread plies or cord, sidewalls, inner liner, and beads. The tread is the exterior rubber portion of the tire that comes in contact with the road. It is configured in a variety of patterns based on the application of the tire, such as for driving in mud and snow. The plies and cords are the reinforcing material that gives the tread and sidewall their ability to hold their shape. The sidewalls are lightly reinforced sides of the tire that provide lateral strength to the tire and prevent it from ballooning. They do not come into direct contact with the road. If they do, it's flat. The inner liner is covering of the casing material that seals the air in the tire. Beads are bands of steel wire coated in rubber that gives the bead area the stiffness to hold the bead against the bead seat and to seal the wheel rim. Tires can be inflated through a valve assembly located in the wheel. Modern tires are made from a range of materials. The rubber used is mostly synthetic with carbon black added to increase strength and toughness. When used in the tread, this combination gives the tire a long life. Natural rubber is weaker than synthetic version, so is used mainly in the sidewalls. Cords of synthetic strands or fabrics have high tensile strength. The tensile strength is the measure of the innate strength of the material. Because of their high strength, the cords resist stretching but are flexible under load. The cords are placed in parallel and impregnated with rubber to form sheets called plies or belts. Plies have high strength in one direction or flexible in other direction. When cotton was used as cord, the number of ply layers in the tire was measured of the tire strength. Newer cord materials use fewer plies. A modern steel belted radial tire with 6 ply rating makes have 6 plies in the tread but only 2 plies in the sidewall. Having fewer ply makes it more flexible. Higher numbers of plies make a tire's response to bumper harsher, but the tire can withstand punctures much better. The beaded attire is made out of cord of high tensile steel coated with rubber. The end of the plies is wrapped around the bead, which is then wrapped in the rubber to stop chafing the plies and also to seal the bead against the rim. The length of the wire used to the bead determines the rim diameter of the tire. Belts that reinforce the tread area of the tire are typically made out of braided, high tensile steel strength, but they can also be made of rayon or polyester. The inner liner of the tubeless tire is made out of soft rubber. The inner liner must be flexible and airtight. The tire valve is a specially designed opening that allows the tire to be inflated, then automatically closes to prevent air escaping. It consists of a valve stem into which a valve core is threaded and is used on virtually all automobiles. The valve stem is a rubber or steel piece that attaches to the valve to the rim of the tire. The valve core is a Schrader valve. It is a spring-loaded one-way check valve. The primary function of a valve stem cap is to assist in keeping the debris out of the valve stem, which could cause the valve stem core to fail. The valve stem cap is removed to check air pressure and inflate or deflate the tire. Some valve stem caps come with a built-in tool for tightening or loosening the valve core. In wet climates, the valve stem cap keeps mud, water, and ice from entering the valve stem. The valve stem cap also can slow a leak from a valve core but not stop a leak completely. In newer vehicles, a green valve stem cap indicates a tire is filled with nitrogen, and to prevent contamination should only be topped off with nitrogen. Types of tire constructions. There are 2 types of tire constructions. One's called a bias ply and then the radial ply. Radial tires are the most common. In fact, one tire retailer estimates about 98% of the tires sold today as passenger vehicles are radial tires. Bias plies are older form of tire and still in use on trailers and off-road vehicles because of a slightly lower cost and their more durable construction. Bias tire construction uses body ply cords extended diagonally from bead to bead at 30 to 40-degree angles with successive plies laid at opposing angles, resulting in a crisscross pattern onto which a tread is applied. This design provides a strong, stable casing but relatively stiff sidewalls. However, during cornering, stiff sidewalls can distort the tread and partially lift it off the road surface, which reduces the friction between a road and the tire. Radial tire construction uses the same body ply cords, but they are laid across the tread, extended from bead to bead, so the cords end up in parallel to each other, approximately 90 degrees to the center line of the tread. Radial tires are extremely durable and maintain good traction with the road, providing better steering control. Most passenger cars now use radial tires, as do most four-wheel drive vehicles and heavy transport vehicles. Radial ply tires have much more flexible sidewalls because of their construction. There are 2 or more layers of casing plies, the cords that give the tire shape and strength, with the cord loops, which are loops of high-strength material, inlaid with rubber running radially from bead to bead. The sidewalls are more flexible because the casing plies do not cross over each other. However, a bracing layer of 2 or more steel belts running horizontally must be placed under the tread to strengthen and stabilize the tire. The cords of the bracing layers may be a fabric of steel or placed at 12 to 15 degrees to the circumference line. This design forms triangles where the belt cords cross over the radial cords. The stiff bracing layer links the cord loops together to give stability when accelerating or braking. It prevents any movement of the cords during cornering. The cord plies flex and deform only in the area above the road contact patch. There are no heavy plies to distort. Flexing of the thin casing generates little heat, which is easily dispersed. A properly inflated radial tire runs cooler than comparable bias ply tire, increasing tread life. Radial tire has less rolling resistance as it moves over the road surface. Hello, Sherwood. Then you have tread designs. The differing tread patterns give manufacturers the ability to design tires for special applications such as rainy, snowy, muddy, highway, or high-performance driving. Manufacturers spend a lot of money trying to design better tread patterns than their competitors, and when they discover a good design, it can be very profitable. The tread patterns can be classified with these general characteristics: directional tread patterns, non-directional tread patterns, symmetric tread patterns, asymmetric tread patterns, and directional and asymmetric tread patterns. Directional tread patterns are designed to provide a range of attributes during particular driving conditions, such as driving in wet weather where there is possibility of hydroplaning. Hydroplaning is the sliding across the water. The predominant tread pattern is mounted in such a manner as to provide maximum moisture dissipation, thereby creating a drier surface for the tire to adhere. Specifically, these tread patterns actually pump water out from under the tire, bringing it direct contact with the surface of the road. This type of tire can only be mounted in the wheel so that it revolves in a particular direction to correspond with the tread pattern. An arrow on the tire sidewall indicates the design direction of forward travel. The directional tread pattern. Non-directional tread patterns are designed in such a way that the tire can be mounted on the wheel for any direction of rotation. This allows the tire to be installed on either left or right side of the vehicle and to be mounted in multiple directions. These tires are used for general applications when customers may not be looking for a high-performance tire. They are usually cheaper to manufacture than specialized tires, and they allow stores to stock less tires. Non-directional tread patterns. Symmetrical tread patterns, same tread pattern on both sides of the tire and are usually non-directional tires. As the name indicates, they tend to feature treads that are similar and continuous designs across both sides of the tire tread as well as around the tire. The main feature of the most symmetrical tires is that they are non-directional and thus can be fitted either direction. This is what one of the stock pictures. I always tell my students this is not really a symmetrical tread pattern. Because which direction do you think this one looks like it's going? Down, right? So I'm like, no, that's not symmetrical. And asymmetrical tread patterns have both directional and asymmetric, which means the tire is designed to rotate in only one direction and has one side that must face outward to ensure that the tire performs as designed under operating conditions. Asymmetrical. Directional and asymmetric tread patterns, both directional and asymmetric, which means that the tire is designed to rotate in only one direction and has one side that must face outward to ensure that the tire performs as designed under operating conditions. These type of tires usually will say outside, inside on the side of the sidewall.
Modern tires are made from a range of materials. The rubber is mostly synthetic, with carbon black added to increase strength and toughness. When used in the tread, this combination gives a long life. Natural rubber is weaker than the synthetic version. It's used mainly in sidewalls. Early tires used cords of cotton, but with increased vehicle speeds and loads,